Hi, everyone. Welcome. We will allow for a couple of minutes for folks to join, and then we will begin our webinar. Thank you for joining. Um, Thank you for joining Diagnostics, the key to optimizing your HVAC upgrade. Hi, Sydney. It's good to see you here. Thank you for joining us. Okay, I'm just going to give folks one more minute, and then we will begin. As you get settled in, please put your name, what type of work you do, and your location in the chat. Let us know where you're joining from. Excellent. We have some folks from Tampa, Florida, Richmond, Virginia, Hudson, Florida, Atlanta, Georgia. Welcome, everyone. Charleston, South Carolina. Good morning. Okay, so in the interest of time, I am going to begin. Welcome again. Welcome everyone to Duct Diagnostics, the key to optimizing your HVAC upgrade. This webinar is presented in partnership with the Florida Solar Energy Center, FSIC, and supported by the U.S. Department of Energy and the National Laboratory of the Rockies. My name is Laura Diaz Villaquiran, and I'm a research associate here at the Southeast Energy Efficiency Alliance, and I will be your host today. If you're not familiar with the Southeast Energy Efficiency Alliance or you need a refresher, we promote energy efficiency as a catalyst for economic growth, workforce development, and energy security across 11 states in the Southeast. We provide research, consultation, stakeholder facilitation, program management, and financial services. And our goal is to help all people in the Southeast live and work in healthy, resilient buildings. Thank you for joining us. Before we begin, I'm going to go over a few housekeeping items. This webinar is being recorded. The recording and slide deck will be available after this call and will be emailed to all registrants and attendees. Please submit your questions in the Q&A box at the bottom of your screen. We'll take questions at the end of each session, and a short survey will appear when the webinar closes. We really value your feedback, so please make sure to fill that out. It's just a couple of questions, so it won't be a very long webinar. And again, as you get settled in, please write your name, what type of work you do, and your location in the chat. I'm going to go ahead and share screen, and I am going to hand it off to Eric Martin, who is going to give us an introduction about this work, and give us a little bit of more information about how this webinar came about and what this project is about.
Thank you, Laura. Good morning, everybody. I'm Eric Martin with the Florida Solar Energy Center. We're a research institute of the University of Central Florida. And this webinar is part of a project that FSEC and SEIA are working on, funded by the U.S. Department of Energy's Building America program. We are one of 9 retrofit solutions teams working with industry to implement best practices. Our project that we call Optimizing Heat Pump Readiness is looking to increase the practice of addressing poorly performing ductwork during HVAC changeout. So we've been collecting data on barriers, opportunities, and benefits from this practice a few different ways. We've been working with a utility program and a program implementer that has programs that help homeowners upgrade their ductwork. And we've also been getting feedback from contractors and other stakeholders through a few different mechanisms. We had an online survey. We've done a few virtual focus groups, and we've also had some one-on-one meetings with contractors. And some of the solutions that we've identified as part of this effort include some advanced tools that help contractors collect data on the performance of the duct system and then help them interpret that data to provide some actionable steps on how they can improve that performance. It also helps communicate the value of taking those steps to homeowners that need to understand why they should be upgrading their ductwork. And another solution we've identified that can help the practice is financial assistance that can help homeowners with the first costs that are involved with upgrading ductwork.
Excellent. Thank you, Eric. Thank you for setting the stage for everything we're going to hear about today. We're going to move into our first section, which is going to be our technology solutions section. In this section, we're first going to hear from three industry experts on the technology solutions that make accurate duct leakage assessments and heat pump optimization. Together, we'll cover diagnostic tools and testing equipment, field measurement and software, and equipment selection and design. I'm pleased to introduce Steve Rogers, the president of the Energy Conservatory. Steve, I'm going to go ahead and let you take over. So please feel free to share your screen.
All right, just a second here. Let me get. Okay. Can everybody see my screen okay?
Yes.
Yes.
Oh, okay, great. So today I'm going to talk about optimizing duct upgrades, and I want to talk about this. Well, first to introduce myself. Why is it not advancing? Okay. So I'm Steve Rogers. I'm the president and co-owner of the Energy Conservatory, and we are a manufacturer of equipment for testing air tightness of ducts, air tightness of buildings with blower doors, and also airflow measurements of HVAC systems. And this is my background. I don't have a lot of time to go through that. But I want to talk about what we do in terms of a process for retrofits. Most HVAC that gets installed is in retrofits. New installations are relatively rare by comparison. But we've been teaching about a process that we recommend for anybody who's doing equipment replacements. And there's 6 steps here. And I'm not going to talk about all of them. I'm really just going to talk about step 3, which is evaluating the existing duct system, assuming that it's going to be reused. But before we get to that, I hope it's not a surprise to anybody that to get the best performance out of a retrofit HVAC system, you need to be gathering information about the existing system, gathering information from the occupants about how the previous system was working or not working. Step 2 would be a load calculation. I hope that's not a surprise to anybody. This can be done in 20 minutes now with the modern LiDAR scanning load calc tools. And then we do the duct evaluation, step 3. Step 4 would be to look at the equipment and selection and scope. Step 5 is to install and set up the controls. And then step 6 is commissioning the new system, a super important step that gets overlooked all the time. And I think Joe is going to have some insights on what to do that with. MeasureQuick is really the best tool available for doing HVAC commissioning. So I'm going to talk about duct evaluation, and let's get started with that. So when you're thinking about a retrofit system, it's really important to evaluate the capacity of the existing ducts. And especially when you're retrofitting a furnace with a heat pump, because if you look at how many BTUs can be delivered with the airflow in the duct system, furnaces deliver hotter air, and therefore it takes fewer CFM of airflow to deliver that the heat. So for the same heat to be delivered to a house, a heat pump needs more airflow. And so that's important to understand what are the limits of the existing duct system. And we're going to do a little bit of sort of theater of the mind here. We've done a demonstration. It's best to do this live, but we're on a webinar, so we're going to have to imagine a little bit. We do a demonstration where we have a contest to see who can drink a bottle of water faster. And we get two contestants on the stage. You can imagine how this goes, a small bottle of water. We get out the stopwatches, and then we give contestant number one a straw, and contestant number two also gets a straw, but the straws aren't the same. Contestant number one gets a great big straw that probably works for even drinking a slushy or smoothie or malt. Contestant two gets a really narrow straw that comes with the juice box. And so think about how this is going to go. I want you to think about, is this a fair contest? And which contestant is going to have to work harder to drink that water? Who's likely to win if we're timing how long it takes you to drink the water? Hopefully it's not a surprise that contestant one always wins this contest, and contestant two feels like this was not fair, and they can't win. And often they report that their mouth is kind of sore from sucking really hard and trying to win the contest. Okay, so what I want to tell you is that ducts work just like straws. And so when I'm going to retrofit a new system with existing ductwork, I really, really need to know, is the existing ductwork like a great big fat straw or like a skinny little juice box straw? And how can I know that? So the way that we recommend is the digital TrueFlow grid. And I'm going to show you what this does. If you're not familiar with this product, this is becoming widely used and popular in retrofit processes, because what's happening is by using this type of evaluation, HVAC contractors are able to predict whether they're going to have airflow problems with the new system or not before they sell the job. And of course, nobody wants to have an airflow problem after the client has paid for everything and something's not working right because airflow is too low. They'd rather know ahead of time, and then they can get paid for any duct renovations that may be required. So the digital TrueFlow grid, if you're not familiar with it, is a system that looks like this. There's the grid itself kind of in the center there, and that snaps into an adapter. The adapters come in many different sizes to match the furnace filter or air handler filter. So wherever the filter is, that's where the TrueFlow grid goes. And then there's a digital pressure gauge, either a DG8 or a DG1000. And you need an iPhone or not an iPhone, but you need a smartphone or tablet, could be Android or Apple. And that connects to the other two devices via Bluetooth to do the analysis. So the way that it works is the app is going to guide the technician through the process of measuring static pressures first and then measuring airflows. So you can see they get an image of the type of system, and this image will change depending on whether I've got a whether I've got a filter that's in a filter slot, or whether it's a filter grill in the ceiling, whether I've got a furnace and cooling coil, or just an air handler with strip heat. So the user will choose those options so that they'll get an image of what they need to measure. And then you can see there's 4 spots here with the manometer is shown connected to the return duct before the furnace filter. And this image will change depending on which type of system you choose. And it will guide the user through making a static pressure measurement with the system in normal operating conditions. You want to get it ramped up to 100%. And with the regular furnace filter in, so just normal operating conditions, we're just going to measure the pressure in 2, 3, or 4 locations to map the static pressure. Then after that, they will put the grid in place of the filter, and make another measurement of airflow and a second static pressure measurement. And then the result of that is a report that looks like this. The two main dials are airflow and static pressure. That's the main thing about airflow is, am I getting enough flow or too much or too little? And how's the static pressure? You can see that this system that we evaluated, airflow is a little too low. We're below the green zone. We're into the yellow caution zone. And the static pressure is really too high at 0.88. Most manufacturers would not recommend that much static pressure. But what's important is we take that static pressure, TESP, and we break it down into the four components. So if you add these four subdials, we call them, if you add them up, they add up to 0.883. And these are important because it can point you to, if you're not getting enough airflow, if you're not capable of getting the airflow that you need for the correctly sized system, then where should you work on improving the duct system? If I were to look at this system here, we'll start at the bottom. Supply plenum pressure tells me, are the supply ducts properly sized? That's right in the middle of the green. That's great. 0.11. I wish every system had that low of a static pressure in the supply plenum. Evaporator coil is a little higher, but that's the existing one that we're probably going to replace. And the filter is also a little high, but usually a new system is going to get a new size filter when it gets replaced. The return plenum pressure, that's in the yellow, and that's really the highest one of the four. So if I wanted to renovate this system, that's where I would focus my efforts. So the first thing I've done here is I've just taken the measurements, I've done a testing of the system, and this takes about 10 minutes. Doesn't take a long time. It can easily be done on a sales call and even with a comfort advisor who's not trained as a technician. So that's the measure in process. That can tell me, so for the system that's installed here, this system is more like the juice box straw. The pressure's too high and the airflow's too low. That's a good place to start knowing that. But how it's going to perform with the new system depends on the new system, of course. So what I want to do next is I'm going to click this forecast button at the bottom here. And when I click that forecast button, it's going to walk me through some information about the new system that I need to enter so that I can evaluate how this is going to work with the new system. So in this case, I'm going to choose that the bottom selection here, I'm going to forecast the performance with a new heating system, not cooling. And I'm going to choose that I'm going to replace this system with a heat pump. And that heat pump is going to be in the form of a furnace and coil. So this is a dual fuel system. It has a furnace with the furnace fan generating the airflow, and then a separate indoor coil that's used for heating or cooling. And that's the information I need to give it to get a forecast. So once I've given that information about what type of system it is, now I get to this simulator screen, and it's going to allow me to predict how that system's going to work once I choose three things. The top slider here is the system heating capacity, and then we get the filter pressure drop and the coil pressure drop. The filter pressure drop is usually available from the manufacturer, but you may need to adjust it for the airflow. So some experience with what you're measuring on existing systems with the filters that you're putting in new will be helpful there. The coil drop, that should be available in the manufacturer's literature. So in these two systems, I have on the left, I have simulated a heating system that is 3 tons, and I'm comparing it to one that's 3.5 tons because I want to know, am I okay with a 3.5 ton system? Let's say I want to replace it with a 3.5 ton system. and but I'm not sure if that'll work. It could be that I only need 3 tons for cooling, but if I'm in a cold climate, maybe I'm trying to make a 3.5 ton work so I can capture more of the heating load with the heat pump and less with the furnace. But what you see here is that the 3 ton system on the left gets my airflow and my static pressure in the green. The 3.5 ton system, actually, the static pressure is too high. That's telling me that the existing duct system, with the information I've given about the new system, is not going to work. The static pressure is going to be too high, or the airflow is going to be too low, or both. And so I've looked up my information about the indoor coil pressure drop at zero point 0.2. Let's say these are both available in an indoor coil that's about zero point 0.2. And let's say with the filter pressure drop, let's say that I happen to know that the size of filter and the filter media that I'm going to install is going to be about 0.15 for 1200 CFM, but that same filter might be zero point 0.2 if I need to move 1400 CFM. So knowing the filters that you use and how much pressure drop they create at various airflows is what you need to do this evaluation of the filters. Okay, so I've done my simulation here. I find out that the 3 ton is not, 3 ton is okay. The 3.5 ton is really too much airflow for the existing ducts. So now I have a choice. This will break down the system into components, just like we saw before in the measure in process. The filter pressure drop and the evaporator coil pressure drop, those are just the numbers that I gave it because I looked them up from the manufacturer's literature. But the return plenum pressure and the supply plenum pressure, those are predicted for the 1200 CFM that's required for the 3 ton or 1400 CFM that's required for the 3.5 ton. So once again, I've got this broken down so I know where should I improve that system. So if I really want to install the 3.5 ton system, where should I focus my efforts to improve the system? And just like before, the return is really too small. You need to, it may be that you've got the drop that's approaching the furnace. It may be that you've got not enough branches from the return. If you've got individual room returns, and the filter is also a little bit marginal at 0.2. So if I've got a bigger filter available, I might want to install that one instead. So in terms of understanding how this works and what problems we see in the field, I'll give you some information about what we often see. So a return plenum pressure that's too high because the returns are undersized is the most common problem for airflow that we see. And so that means adding a branch to the return. It might mean enlarging a trunk if it's a trunk and branch system. It might be the plenum's too small. So that's the most common problem that we see for airflow. Also quite common is filters that are not large enough or not deep enough. So if I've got a 16 by 20 filter on a 4-ton system, a 16 by 20 by 1, for example, on a 4-ton system, that's not big enough. It will always cause a major restriction on a 4-ton system. And deeper is better. Normally, if you go from a 1-inch deep filter to a 4-inch deep filter, approximately you'll cut the pressure loss in half. And if it's apples to apples, if I've got the same brand and the same MERV rating in a 1-inch or a 4-inch deep filter, usually the 4-inch deep will have something like half the pressure loss. Okay, now what about the evaporator coil? That's a less common restriction, but it is still fairly common. And what we find is that the reasons that a brand new evaporator coil would be too restrictive are because it depends what you ask for. If you look through the manufacturer's literature, there may be 3 different coils that you could use for a 3-ton system or for your 3.5-ton system, whichever you're going to go with. but they're not the same size and they don't have the same pressure loss. So if as a technician, you just walk into the supply house and say, I need a 3-ton indoor coil, the one that they give you might be the one that's physically smaller and therefore has a higher pressure loss. So you need to do your homework and find out, oh, there's 3 different models here. If I want to not have a restrictive indoor coil, I need to order the one that's physically bigger. And that's usually what makes the pressure loss lower is it's physically bigger. Maybe it's an N coil instead of an A coil. Maybe it's an A coil that's taller, so there's more surface for the air to go through. So that's what we see for evaporator coils. And then supply plenum pressures being too high are fairly uncommon. That's not usually where the bottleneck is. Um, it might be the bottleneck to one room, like maybe you've got one room that has a 6-inch branch and it needs an 8-inch branch. But that's relatively uncommon. It's usually the other 3 are where the restriction lies. But the good thing is if you do the test with the TrueFlow, it will point you in the right direction to find out where is the problem and what can I do about it. So that's a new tool, fairly new tool. It's about 5 years old that we've been selling the TrueFlow that has the app to back it up. So that's what I can tell you about the TrueFlow and how it can help with the retrofit process, making sure that the duct capacity is capable of moving the airflow that is needed for the system. So what airflow is needed for the system, that's doing your manual J load calculation and manual S selection to find out what system you need. Then you'll know if then you can evaluate the duct system for that capacity. Okay, so that was most of what I want to talk about, but I'm going to spend just 2 slides here talking about something that I think is probably even more important than what I talked about, but wasn't the topic for today. And that is, I'm going to ask you, you got 2 different problems with the house here. The one on the left, that's clearly a climate zone 6 kind of problem. Those in colder climates have probably seen some ice dams before, since this is, but since that we're on a conference or on a webinar by SIA and FSEC, the one on the right is probably a problem that's more common in the Southeast. And I want you to think about, have you seen these problems and what causes these problems? These 2 problems have something in common. In fact, they're probably caused by exactly the same thing. But the result of what they cause is completely different because of the climate and because of the way that the system is put together. And the thing that they have in common is duct leakage to the outside of the house. So anytime ducts are not completely inside of conditioned space, we can have a problem that we call duct leakage to the outside, or duct leakage, outside of the conditioned envelope. And I want to acknowledge that this work was done in the, I think, late 80s, early 90s, and FSEC was a big part of why we know this and why we know what a big problem it is. Research was done back then, and it was found to be a big problem all across Florida. And here's how it works. Anytime there's ductwork in the attic, let's say we've got a system in a closet that's inside the house and it's moving 1,400 CFM, let's say it's a 3.5-ton system. But there's leakage, and so only a little over 1,000 of that 1,400 CFM is coming back into the house, with the remaining 400-ish CFM leaking into the attic and then falling out the soffit vents or going out the ridge vent. It's probably heavier than the air that's in there, or because it's cold air. But when that happens, there's something important that happens, and that is it's not just that you lost like a quarter of the airflow. It also caused a pressure imbalance. What happens when you suck 1,400 CFM out of the house and only put 1,000 back in? Well, the pressure in the house is going to go down, and it's going to keep going down. In this case, we're saying it lowers the pressure in the house by 2 pascals, which seems like very little. But in this house, it will lower down to whatever is needed to make up the 384 CFM that got lost through leakage. So every cubic foot of air that gets lost through leakage has to come back into the house. And we know that because houses don't implode because of this problem. And the reason they don't implode is because they have holes in them and the pressure will go down until the airflow is balanced. Now I've got a 1400 CFM leaving the house and 1400 coming back in because 1000 is coming back in the supply vents, but the other 384 is getting sucked in every crack and hole and leak in that house, bringing in hot, humid outdoor air. So the photo of the HVAC closet being full of mold is because there was a leak around the top of that where the duct goes through the ceiling was not sealed. And so the negative pressure caused by duct leakage into the attic depressurized this so that now we're sucking attic air that's very hot and humid into the closet, which all 4 sides of this closet are up against conditioned space. So those walls are cool, cool enough to condense water and grow mold. So that's just a quick plug. If you don't know about duct leakage to the outside, if you're not doing duct leakage measurements, I recommend you look at that. That's a huge cause of humidity problems, of moisture problems, of comfort problems, and it costs a ton of energy too because you're blowing expensive conditioned air out through the attic. Nobody wants to do that with the expensive air that they paid to cool. So that's all I have for my presentation. Do you want to do questions at the end, I'm assuming?
Yes,
Laura? Yep.
some questions are popping in the chat, but we will let this section continue. And then once our first three speakers wrap up, then Dr. Amy Lovell is gonna lead us through that Q&A. Thank you so much, Steve, for giving us such a thorough explanation of airflow, duct leakage to the outside, and for sharing that analogy with the straws. I'm going to pass it over to Joe Medosh from MeasureQuick. Joe, you can take it over.
Great. Hopefully I'm up and running. Do you guys see that?
Yep.
Great. Okay. So there is a lot more that we can cover, and there's some really powerful names that are here in the backside here. So for those of you that are doing true flow, or you're doing duct leakage, or you're doing whole home assessments, or a variety of other stuff, please chime in and tell people what you're doing and what do you regularly do, because some people are still trying to figure out this process here. The one thing I do want to highlight on what Steve just finished, which is incredibly powerful, but it also is incredibly dangerous. And when you have a lot of supply duct leakage, the house is going negative. And if you've got a domestic hot water tank in the house still, that's actually natural drafting, you can actually backdraft that appliance and actually cause carbon monoxide issues and other combustion issues in the house because of duct leakage. So these are some of the things that you were doing and not realize that if you seal up the return, maybe now my supply is still leaky. So these are all things you need to be doing. And this is fundamentally why BPI became as powerful as they were, is you always need to be checking when you have combustion appliances in the house, and duct leakage alone can actually cause some of these issues. So thanks for pointing that out, Steve. Well done. Okay, let's dig in. So there are so many studies that are out there that are just showing that we don't do a good job with HVAC systems. In fact, this is one that I've used and it's been rewritten many other times, but 70 to 90% of HVAC systems have energy wasting conditions. These are faults that are in the system that are problematic. And if you add duct leakage, it's almost 100% of systems have an issue. That so many homes have significant duct leakage. So these are some of the challenges. And this is actually the illustration on the right is just regular air conditioners and air source heat pumps in cooling mode, right? Let's elaborate here. So if we go forward, this is actually air source heat pump in heating mode. These are the things that we're failing to try to convert this. Oh, let's go into heat pumps, heat pumps, heat pumps. And many people are not doing a good enough job of diagnosing the existing system they have or confirming that what they're installing is installed correctly. And airflow is a major significant part of that. So the whole duct concept has got a lot to wrap around. It's actually, we think of it as like, oh, it's so there and part of all of our homes, and that we're not actually acknowledging some of the conditions that we really should have been paying attention to. Most of the times if you knew that there was a duct concept or that was in the title, you'd be seeing stuff like this. Like we're doing, total pressurization or depressurization and total leakage, or even more complicated leakage to outside. But this was a surprise for me because I came from this world. I actually worked with SEA a long time ago. I lived in Georgia. Georgia was one of the first states that required duct leakage and the blower doors back in 2013. That was 10 years ago, even more, 13 years ago. So it's been around for several areas, but is it actually enforced and done? And I now am in the HVAC world and out of more of the energy and IEQ, and I'm stunned at the few people that are actually testing their ducts, evaluating airflow, or doing anything to figure out what are the real problems, because it's the boxes are usually fine. It's how do I get from A to B that's actually causing all the issues. So this was kind of a major disappointment that the amount of people that are really assessing that. And there are some great folks on this call that are in the background that do this and do this well. So chime in if you got advice about how you could recommend other contractors. The analogy that I usually give somebody, if you're going to get new tires, I'm like, oh, we need new tires. It's that time of the year. It's expensive. And the tire person put them on and says, I really don't have a tire gauge. I think that the amount of air that's in them is good. So come back if it's low, and we'll put some more air in it. So if you're installing ducts, you're using ducts, if ducts are a part of your process that's in your HVAC world and you are not measuring the conditions, then I'll be honest, I kind of say shame on you, because there's so many ways to do this now that the duct tester is clearly the most obvious, but we're now moving into another world where we can use things like the TrueFlow grid and other complementary stuff to kind of confirm, is it performing correctly? And even maybe can I extrapolate, is there potential leakage in this system? So this is our normal duct leakage test, all right? And we're now moving past this and getting into other options. So NCI and other folks are promoting that I could use my TrueFlow grid to actually get a total measurement out of this. So that's the greatest thing about that. And there is no greater tool that's actually on the market right now that actually assess static pressures, which most people are not measuring either, and airflow all in one quick step. This is actually usually if you took 10 minutes to do this test, it was probably because you actually were first time doing it. It goes fairly quick, and you can get all your measurements and you find out what your total flow is. Once I know what the flow is after my return, I could actually go around and use a simple hood and measure the supplies. And this is a estimated leakage, but if I have so much the airflow that's coming out of my unit and I go figure out what are my supplies, there's an indirect concept now. Like I can kind of estimate that, do I have a lot of leakage? And if I know where my ducts are, then it would be leakaged outside. So there's a lot of ways to actually now to kind of confirm what are my issues and my challenges between airflow and duct supplying back into the house. So a lot of great training out there on this kind of stuff. So NCI is a number one source for using these kind of methods and promotes this regularly. And this is nothing new. This has actually been around since the ACA has been promoting the QI5, which is, again, you're designing your system. You are testing the ductwork. You are doing airflow measurements, and you're balancing. So this is something that's built into MeasureQuick as an option, as the highest performance you can actually do. And this is not a really major challenge. People are like, oh, QI5, that's so hard. And the reality is it's actually very achievable. And lots of contractors across the country are doing this on a daily basis. And it's not that it's a possible task. They are differentiating themselves from others because they're actually verifying and confirming their performance with design and multiple tests. So I should introduce MeasureQuick, because many of you may be familiar with TEC and the TrueFlow grid and the duct tester and the blower door, but MeasureQuick is something that still is a little mystery for some people. And we are a diagnostic application that's brand neutral. We actually work with a whole lot of other apps that are out there. These are all Bluetooth wireless tools. We gather them all together and then provide a variety of diagnostics based upon what you're reading. And one of the ones that's on there is the DG8 and 1000, which also means you're allowed to use the TrueFlow grid integrated into MeasureQuick. It's a great opportunity to do two great things in one time. But in general, we're usually the first stop to find out, is the system having problems, and what can we do to upgrade it or make it be more functional in terms of getting efficiency and performance out of it. So that's really our main focus. And we probably work with a variety of tools that you've got there. This is what you're going to get out of MeasureQuick. You're actually going to get a score based upon the measurements that we did from all of our probes. And they're giving you refrigerant charge and heat transfer, air distribution, whether or not your refrigerant's working well, and your airflow is also working well based on our measurements. So you can use the TrueFlow grid, or we actually have our own method for measuring airflow with psychrometers. But in general, now I actually have an actionable number and actionable report to talk to my client about as to what are the things we need to be doing. Or maybe this is an older system and now it's time to start thinking about how do we upgrade or move into that. Or maybe there's a great rebate in your area like there is in mine where you actually it's worth your time to look into getting a really good heat pump that's going to replace your existing system. Whether it's dual fuel or not, that depends on your climate and your rebates. But in general, many people are looking to do this, and it's a great option to give people more ability to control their comfort zones. These are the manometers. These are actually all of the tools that we're using. So we have two manometers. We have three psychrometers. One's outside for outdoor air. We've got refrigerant pressures and temperatures, and the electrical is an option, but those are all things that you would do. And those are going to give you your vital score, which I just showed you. It allows you to benchmark your system. So when people come back, they can confirm if it's working well. We also do live streaming where I can actually have one technician stream their information live back to the shop or back to other technicians. These are all of the fundamentals that MeasureQuick is built onto. So it's not a snapshot of measurements. These are actually all 9 probes are on all the time, giving you live information, and they're completely dynamic that actually are highlighting exactly what it is you need to know about this system while you're there at the time it's on. So here's the probes real quick. So inside, I've got one at the return, and I have one at the supply. These are not in the unit. Notice that we're not actually measuring the appliance, we're measuring the system. So this is where duct leakage outside and a variety of other stuff gets confirmed with the measurements that we have. We actually know your temperature, what your temperature split should be. And if your ducts are in the attic and it's a hot day, we actually could give you an estimate that you probably have duct leakage because your temperature split's too high. You're bringing in outside air into your ducts and your return's high, so we would actually give you that as a diagnostics. But our supply is actually in the register. We want really good temperatures from inside, not just what's on the face. So these are 2 of your indoor. The other one is you wanted to be doing your static pressure. This is something that everybody should be, if you're an HVAC contractor, you're doing energy diagnostics, this should be done every time because you never know when the homeowner decide to go get the brand new super, MERV 3000 filter and try to block the airflow, thinking that they're also going to capture every particulate known to man. And they only restricted the airflow that was on there that caused not just airflow problems, but a variety of dynamic problems altogether, including what may show up in your refrigerant charge. We'll talk about that in a second, but this is one of the easier actually evaluations. This is part of what the TrueFlow grid is doing also. So if you want to kill 2 birds with 1 stone, the TrueFlow is going to give you these similar measurements plus more. They're actually going to do something more of a screening. So this is built into the NCI screening, which is in MeasureQuick. This is also in the TrueFlow grid app itself. You actually can do a static pressure screening by itself, which is just trying to just do static pressure. If you didn't have the grid, you can still do great diagnostics with their app. So, or with MeasureQuick. These are all free options that are in both our apps. So if I want to find out if my return is too small and I have restrictions, or my filter is restricting, or my coil or my supply, whatever those things are that Steve kind of highlighted a few minutes ago that are on their report, these are the same things you're getting out of MeasureQuick and the NCI static pressure screening. So I could know within a few seconds as to what are my actual issues. And as he highlighted, a lot of times it's the return is too small or they've got a restricted filter. Those are things that are a lot easier to correct. And a lot of times they're actually really near the unit itself where I'm getting my great restrictions. If not, you're trying to figure out how do I make this as part of my upgrade in diagnostics. These are what's outside. So I had 4 inside. These are my outside probes. So I'm basically just measuring the refrigerant pressures and temperatures. And I have an outdoor air temperature, which gives me guidance as to how well everything is performing. Those are all of the 9 probes that you need. Once all those 9 probes are on and the system is at its full capacity, then I actually can give you great diagnostics as to what's going on or what the problems are. And there are some logistics where we talked about ducts and duct performance and airflow. So some of those will show up indirectly or directly in MeasureQuick. So you get free diagnostics in MeasureQuick. We do have options if you want to get more premier features, but in general, you can just get the probes, put them into MeasureQuick and get these free diagnostics. So it's giving you this great information that's on there, and they're all actionable. You click on any one of them that gives you information about what you should do next, links you out to Brian Orr's HVAC school for more information for a lot of this stuff. So it's all live data built into to MeasureQuick. I could totally spend a lot more time on it, but in general, Between our two tools, you can actually do an amazing assessment as to what's going on with this system. And if you think it's an outside issue with refrigerant charge, you need to be going to measure airflow before you make any adjustments with refrigerant charge. It's a real common problem in our industry that people are like, oh, I think it's low on charge. Oh, you need to pull some charge out. You need to find out if the airflow is correct. And the airflow doesn't happen visually. You must use a tool to measure airflow. And there's really the one that's the most accurate and the most dynamic is actually the true flow grid. There's no other better way to measure true airflow than with the grid. These are some of the things you get there. Notice that system may be overcharged, but at the top it says potential return duct leak or energized heat strip. It means that our temperature split is too high. These are all the things you're getting in Measure Quick as part of their free diagnostics. And it's telling you what to do and what to look for and how to step through those. We do offer some other premier services. So if you want to use our subscription, it's there. But I just thought I'd highlight some other options. So if you do need these other conditions and what these are, there's something you can reach out to us and we'll gladly assist you with that. But in general, the diagnostics I mentioned a second ago are all part of the free process that Measure Quick includes. I tried to visualize and see if we couldn't explain that maybe you did design and commission a 400 CFM unit. And then you've come up later and find out that, well, and now it's, we'll just say I haven't measured it yet, but I sense that there may be an airflow problem. And when I did measure it, I found out there's only 330 CFM, and people are failing to inspect these conditions before they're checking refrigerant charge. So I have a dirty blower wheel, I've got a dirty coil, I've got a dirty filter. All of these things are going to slow your airflow down. And these things are going to cause problems, not just system-wide with your airflow, but they're going to show up dynamically. And the other one would be if somebody set the speed wrong. There's a long list of stuff that could be happening with wrong motor, wrong settings, a variety of stuff that wasn't done initially, but people felt that there was cold air or hot air and they just ran out the door and all was good. So in general, these can actually create misdiagnosed refrigerant measurements outside that I may have a really low superheat or my subcooling could be off. There's a variety of conditions that would show up in my pressures outside and my temperatures that I'm getting on my refrigerant unit outside of the condenser that are really caused from actually airflow problems inside. And so we just want to make sure we remind you to be cautious about just adjusting the refrigerant to actually confirm whether the system is operating correctly without doing proper visual diagnostics and measurements of actual airflow. This is one of the greatest problems we have in our industry is people think everything's fixed with refrigerant, either more or less. So again, a fundamental rule is you need to make sure you not just confirm everything is clean and working, including the coil outside, but now I've measured what my airflow is. So I like that Steve had a one of those guides, and I started to be like, oh, I'll let ChatGPT do the chutes and ladders. So a lot of the stuff that we'd be doing would start with Measure Quick. If somebody's out doing Measure Quick, they do diagnostics and realize that we have an issue, or they want to upgrade to a new system, maybe heat pump. So you are starting with the manual J, S. You can probably bypass the D if you jump on the ladder and go up and do the true flow grid and use the forecasting method. So now my forecasting method is going to tell me whether or not these ducts are sized correctly for my system that's there, or maybe they just need a few tweaks or adjustments to try and get the airflow out to certain areas. So I'm sealing it up or determining what I need to do to adjust those ducts, and then I jump up and make sure that my registers and my filter, and I have to use the true flow grid again after I put in a new system to commission it with the airflow and then confirm it with Measure Quick to confirm that I actually have the correct refrigerant charge and the correct airflow. And now I'm able to get a score out of that final. So here's your HVAC chutes and ladders games. You can stay at the end. I'll show you how to get your copy. But in general, notice the slides that are taking you back down. If you're just going to the refrigerant side, if you're only using your gauges, you are falling back to the question mark on scratching my head on number 5 because they didn't do their assessment. They didn't use the true flow grid. They're bypassing the tools that are out there for them. So unfortunately, that's number 5 is a common scenario that people can't figure out why adding or removing refrigerant is not the answer. This is Jim's Bergman's concept of what is a fail-proof process. So you can size the system well. You can get a quick manual J in a matter of minutes with using conduit or amply as a approved manual J ACA approved process that actually walks you through the house and tells you what you should be doing. If your ducts are super bad or you need to make them tighter, which is a cautionary tale for heat pumps, you can use AeroSeal and you're going to forecast with TC once you've got your ducts in line and know what you're going to do if you replace something. All right. Next is we're selecting our equipment. We evacuate with the AccuTools or a similar system, and we set the airflow again with the TrueFlow grid, right? And when you're done, you can commission with MeasureQuick and even prove it with doing more of an ACCA manual J process. So this is the fundamental methods that are out there. Unfortunately, so many people are really not following through with doing some of these additional testing to confirm. If you don't test, you're guessing. That's a common theme that's been out there for quite a long time. That's me. Please reach out if you want to learn more or understand more about what Measure could do or how we work with the TrueFlow grid. So I appreciate you being here, and hopefully together we can slightly increase the amount of people that are improving ducts throughout the entire country. Thanks a lot.
Thank you so much, Joe. Thank you for walking us through those energy diagnostics and Measure Quick. Now I'm going to pass it over to Ryan Burrell. He is the Business Development Manager for Energy Efficiency and Electrification at Daikin Comfort Technologies. Take it over, Ryan.
Can you guys hear me okay?
I'll go with okay.
Yes.
All right. Sorry, try to make sure I can share my screen. Can you guys see my screen all right?
Yes, we can see your screen.
All right, my apologies. All right. Yeah, good morning, everybody. Thank you all for taking the time and obviously having me, and thank you to SIA and DevSec for hosting. Yeah, my name's Ryan Burrell. I'm Business Development Manager at Daikin Comfort Technologies. I focus specifically on energy efficiency and electrification strategies. And today I really wanted to focus my portion on, Duct Diagnostics, but that relationship between rated performance and equipment efficiency, rated efficiency, versus installed system performance and real world results. Let's see if we can get this going here. All right. So I'm gonna jump through this. Yeah, that's a little bit about me. That's the system I installed at my house. Yeah, I can get my hands dirty every now and then. All right. So if you guys know me, I'm one of those folks who love to start off every presentation with a quote and trying to get the mindset right for the talk. And so I've had these quotes: "Learning and innovation go hand in hand. The arrogance of success is to think what you did yesterday will be sufficient for tomorrow." And I think that that quote's very fitting for where we're at in the HVAC industry. I think we've been in the middle of some major transition recently, and we're not simply swapping out old air conditioners and furnaces with slightly better versions of the same thing. We're asking the market to adopt more advanced heat pump technologies, more inverter driven systems, more connected controls, more grid interactive equipment, more utility aligned efficiency strategies. But the uncomfortable truth with all of this is advanced equipment does not automatically create advanced outcomes. But as for innovation, we have to be prepared as the industry. And that's really what I want to focus on, making sure that we kind of bridge that gap. Okay. All right, the performance gap. Equipment ratings define expected performance and potential. Installation and operating conditions determine delivered performance. So, as equipment ratings are based on defined test conditions, match components using very specific operating parameters. Installed systems operate in real homes with real duct systems and are controlled by system optimization engineers, or what I like to call real homeowners. The importance of the relationship between system performance and the duct system. Well, since our industry loves car analogies, if these two vehicles race each other, who do you think would win? If these two vehicles race each other, but both vehicles had 4 flat tires and both drivers were under the influence, who do you think would win? We don't know, right? Obviously, the car on the left would win, and I think that's the duct system is seriously, it's like the tires of our vehicle. It is a great equalizer for equipment, and one could say technically. All right, so the common installation faults, and I have a lot of empathy for installers. I've installed equipment I know how it feels to be in a 130-degree attic on a hot summer Georgia day. We when does most of our equipment get replaced is during the summer months. When is the less likely time or most safest time, I would say, for being in the attic is probably not during the summer. So there's a lot of confusion with using the right materials. So I truly have empathy for the installer and what the information they have and what they are able to do. But it's kind of that situation where it's like they tell you to use UL 181 listed tape. Well, if you try to use UL 181 red letter tape in a 130-degree attic and you happen to sweat a lot like I do, then that stuff does not stick very well. It's a flex to sheet metal to anything. And so having that using the something like foil tape, which is what we don't want to use, that happens to stick. So like there's a lot of situations where you just have to understand, like installers are doing the best with what they have, and they have no intent. They didn't wake up that morning to do something wrong, and if anything, it might just be a lack of information. So I put all these common insulation faults. I don't mean to obviously discuss or bash installers or anything like that, but this is a reality. Homeowners are purchasing 13, 14, 15, 16 SEER equipment every single day, and they are truly only getting potentially 6, 7 SEER the equivalent to, because of all these installation issues. All right, I'm going to highlight a few. All right, so when does that system performance and efficiency deliver on those equipment ratings? Well, high efficiency equipment delivers on its rated potential when installed systems are properly designed, applied, configured, measured, commissioned, and verified. Obviously, those guys are wearing Daikin shirts, so they're installing that system correctly. No, I'm just kidding. But no, it's true. Like there's a process, and we have to. I mean, there's specifications for that process, and we have to follow it to the T. What is that specification? ACA Standard 5. ACA Standard 5 has been out for quite a while, but this actually defines what a quality installation looks like. That's the acceptable procedures for measuring airflow. I listed all those common installation faults, and with those common installation faults, a lot of them had a theme, and that was airflow, sealed ductwork, and basically what Steve and Joe were talking about, and the tools that they have to be able to measure this is something that that we don't always have access to. So to be able to do this with the tools we have today, it's just a huge advantage. So ACA Standard 5 breaks down where faults or different aspects of it, and I kind of wanted to highlight you have the design aspects. Things can go wrong there. You have distribution aspects, like we've been talking, like we're focused on today. We have equipment installation aspects, and then we have making sure that proper system documentation and the homeowner and end user actually are educated to use the system properly. So important considerations highlighted in our Standard 5. Manual J room-to-room load calculations have a critical role in properly defining the spaces CFM requirements within your manual D duct design. So if you get that wrong, you're going to start everything's going to end up being wrong, because those results are then also a critical piece in determining what your sensible latent heat split ratio is. And then that's the foundation for forming your manual S and selecting the appropriate equipment. We talked a little bit about room pressure and airflow imbalances, how those create real customer complaints. All right, I'm gonna speed up a little bit. I know. Southeast HVAC system retrofit realities: cooling capacity, heat pump heating, humidity distribution. That's what we're really focused on. We're really focused on obviously controlling moisture, in and out of the home. So Key points, ducts are often in attics, crawl space, literally the worst places, typically you could ever want them. Duct leakage, add sensible and latent load, poor airflow can show up as humidity complaints, reducing, oversizing, and all those installation faults end up kind of compounding. So, measuring airflow, controls configuration, balance points, staging, auxiliary heat, those are critical pieces to making sure our systems are performing correctly. All right, so what's Daikin doing about all this, and how are we trying to change the game in helping, at least from new equipment installations? So our Daikin One cloud services, we are now, and this is currently available for contractors, is we can provide quality installation verification reports with majority of our inverter heat pumps and AC furnaces, our Daikin Fit line, as long as they're using our one cloud services platform and controllers. We actually have the ability to provide commissioning reports. What we've been talking about, actually measuring and verifying how the actual installation is going. So guided installation, charge calculation reports, charge verification reports, actual commissioning, telling us what capacity, how many BTUs, whatever you sold that customer, or whatever you promised to deliver that customer in BTUs, you can actually stand behind. We also have, some indoor air quality sensors, as all of those are becoming more and more prevalent in the marketplace, and making sure that we can, our homeowners becoming more aware of their environments with all the technology now. As far as tools and contractor training, HVAClearningcampus.com, we host that, and then we also have the interplay learning. So we have the like technicians who can actually install our equipment in virtual reality. Have it, like a lot of our folks in our industry, we learn by our hands and doing, and so this gives a different aspect into how a contractor can learn how to install these advanced products and advanced heat pumps and inverter systems without actually embarrassing themselves in front of the home. And so I just want to end on this last part. High performing HVAC system installations are produced by installers and techs who possess the appropriate knowledge, tools, and materials to perform the installation. They don't cut corners. They know the importance of a properly designed, sealed, and insulated duct system, especially when it comes to the equipment's performance, capacity, efficiency, and lifespan. And they take the time to measure and verify their results. That's a huge piece. All right, and that's.
Thank you so much, Ryan. Thank you for highlighting that critical relationship between system design, installation, and diagnostics. Now I'm going to pass it over to Amy to lead us through some Q&A.
We can do that, Laura, or we can do the Q&A after the next presentation if we want to make sure we get everybody a chance.
Yeah, excellent. I'm happy to pass it over to our next section, which is going to be on financing. So now we're going to turn to a question that is on every contractor's mind. How do customers pay for this? We're going to hear from Matthew Brown, who is going to talk to us about understanding financing opportunities. And Matthew is the co-chair and managing member of the National Energy Improvement Fund, one of the country's leading organizations in energy efficiency and electrification financing. Welcome, Matthew.
Thank you so much. Give me 2 seconds to get the proper screen shared. Okay. So, well, thank you very much. It's a pleasure to be with you all. Actually, it's interesting. We're in the kind of last phases of design of a launch of a new financing program for energy efficiency in the state of Georgia. So the timing of this call and this webinar is actually pretty apt. What I'm going to do is I'll keep this fairly brief, but I want to just kind of this presentation to provide a bit of an outline for how we, as a lending company that is very focused on energy efficiency, how we interact with contractors, um, how we help contractors to sell more of what they sell, i.e., to sell more energy efficiency and energy efficiency products, but using the financing that we offer. So part of this, I thought it might be helpful to simply draw from a few of the slides that we use when we are presenting to contractors to give you a good sense of how we interact with contractors. So maybe just a little, just a quick minute on who we are. So National Energy Improvement Fund, we are a certified benefit corporation. That means that we are a for-profit, as I like to say, a for-profit with a mission. The mission is to make it affordable for homeowners and businesses to reduce their climate impact by using energy efficiency, electrification tools to do so. We are a lender. We're both a commercial lender and a consumer lender. We also provide advanced funding for energy-related rebates. I'm going to focus here on the consumer side of this. So we are a consumer lender. We work across the country. We lend in 48 different states at this point, and we are very, very focused on, again, on energy efficiency, and in particular working with programs, utility programs, state programs, and so on, like the one I just mentioned with Georgia. I think we have what we call it's a simple interest, meaning it is a simple fixed monthly payment. Our interest rates do not do not change for customers, and we really do all kinds of financing for all kinds of different home energy improvements. It's an unsecured equipment loan or equipment secured loan. The idea is that a contractor can be in a home, can work with a customer, can present a scope of work. That customer can apply online through our system, get an immediate decision. There is a credit pre-screen tool that we use, or that contractors can use, to even know before they go into the home if the customer is going to be able to qualify for a loan. It is as I say, a pre-screen. It's not running credit, not running full credit on a customer. And the other feature is when we're working with contractors, we really focus on making sure that payment goes out to contractors very, very quickly. Typically, we're going to look for a customer to sign off on a completed project and on a certificate of completion, and we will pay next day to that customer. So really, in the end, our goal as a company is to help contractors to increase their sales of energy efficient equipment, and to use financing, to use our tool to do that. So a few different elements of what we do. One, I just mentioned this, the credit pre-screen, easy application, kind of pre-screen a customer that does not impact their credit. It's what we call a soft pull for credit. And customers then can apply. And you'll see in a second, we have a monthly payment estimator, so that even before there's a customer has applied and had their credit pulled, we can give a very, very good idea of what that customer's monthly payment is going to be. Again, immediate credit decisions. It's kind of amazing to me still how many different integrations our system has, whether it's with a credit bureau, or whether it is with identity verification, whether it's with property verification. There's so many different integrations that are happening in our electronic system behind the scenes. But in the end, we have energy lending specialists who are working every single day to help customers to complete applications, and then coordinate very, very closely with contractors to make sure those contractors know exactly what's happening with a project and with the funding. Everything that we do is electronic, and including that application. So just to give you a sense, I grabbed this slide from a contract that we're doing with a large generator company. But you can it's the same kind of thing, and you can kind of see when contractors are using our system. You can kind of see, loan sizes go from 2,500 up to 50,000, terms out to 12 years. There's a pretty wide range um, of products that we can finance. And again, and this is really critical with any type of home energy financing. It is not done. We do not do it as a mortgage. The whole idea is to really do it as quickly as possible, and as cheaply as possible. So we could get into different discussion about the value of things like energy efficient mortgages, which some of you may have heard of. This is not that. This is a very quick credit-based structure, and you can see our rates. This is a non-subsidized rate. So a non-subsidized rate is for about 85% of the customers that we serve is at 8.99% rate. That's just a straight up market rate. What you'll see is that falls kind of on I'll say the lower end of the middle of what you're going to see. You will see some credit unions who might have lower rates. Typically, their process is going to be more of go into the credit union and apply for the loan at that credit union, as opposed to a kind of kitchen table type of transaction. So I'm not going to go into this in detail, but it gives you a sense of the basic terms for any type of loan that we do. The the other thing that we really try hard to do is to make it easy for a contractor to um, uh, essentially have their own page on our site that shows the types of products that they offer. One thing that we do is we offer a lot of different products that may be subsidized by a state, subsidized by utility. So this page would indicate, such and such a contractor is able to offer. Maybe there's a 0% program. We do, for instance, in New Jersey, we do a lot of 0% financing programs that contractors can offer. So that shows up on this contractor's page that is on our site. And you can kind of see the ability the contractor has to do monthly or monthly payment estimates. So instant credit pre-screen, and that's kind of the high level of what we do. I think that the main point that I want to really make here, though, is what you've seen is that we really try to work with contractors and support contractors. The idea that we've kind of based a lot of our financing on is that our financing really is meant to be a part of the sale, kind of fully integrated into that contractor's sale. So we really try to make sure that contractor is as well trained as possible on the types of financing that we offer, and is able to really and not just say to a customer, okay, here's your job. It's going to cost you $12,000, $20,000, $8,000, $50,000. The message is it'll cost you $300 a month, or whatever that is. So the customer is really focused on that monthly payment. Ideally focused also on the energy savings and the upgrades to their home. I think one of the earlier speakers mentioned that we like to kind of talk about what we do in terms of cars and such. The way when we talk about financing, the idea is really the financing should really be very similar to or as easy, frankly easier. I hate buying a car at a car dealership, but easier than the integration that car dealerships have with financing. So idea is integrate it with the sale, make it easy, make it fast, make the payments fast, keep rates down as much as possible. So that's what I got to say. Thank you very much.
Thank you, Matthew. Thank you for walking us through those financing opportunities. Now I'm truly going to pass it over to Dr. Lovell to lead us through Q&A.
Okay, Thank you, Laura, and thank you so much to all of our panelists for wonderful presentations. So please feel free to drop your questions into the Q&A. Panelists, if you see a question in the Q&A that you feel like you can type a response to, feel free, or we can have you go live and answer those. I also want to prompt for anybody who wants to okay, it's fine also to drop it in the in the chat if that is easier. I also wanted to say, as some of you were talking about using these tools, if you're using MeasureQuick and TrueFlow tools, either one, or using them together or using them in combination with other tools, please drop those in the chat. We would love to know how those are being used. And if you have any wisdom for integrating and communicating financing options, as Matthew just discussed in your with your customers, we would love for those to go in the chat or in the Q&A. So it looks like while we're waiting for some things to happen, Steve, do you want to take the question about you use the technical term work in the water analogy? Can you explain how work translate to power and energy? There's also a follow-up question. I mean, it's not really a follow-up, but there's a second question about increasing ceiling and not capacity. Can you handle those
Yep.
questions? Thank
Yep.
you.
Okay, so the term work in a physics and engineering perspective just means an amount of power times time. So if I'm putting 100 watts into the blower fan over a period of time, then that creates to both that gives me an amount of work. It also gives me an amount of energy. So it's really the same thing. If I double the amount of work that the blower fan is doing because the static pressure is a lot higher, then I'm going to double my power bill for that motor at least. Now, the blower motor is not the whole power consumption of your HVAC, but it does matter. So that's when we talk about who's going to have to work harder because the ducts are undersized. That translates directly into a bigger power bill. To answer the other question, I saw that, and if I'm going to share my screen here very briefly, Sydney brought up a good question that I have heard a couple of times, and that is, if I seal my ducts, is my static pressure going to go up? Is my duct capacity going to go down? And I have one very well documented data point on that, which is not great. Nobody wants to work on one data point, but I always say one data point is better than zero. So technically, yes, if you seal ducts, the static pressure should go up and your capacity that you can move through them should go down. But I think based on the one data point that I'm going to show you, I think the answer is it's probably a lot less than you think. I did an AeroSeal on the duct system in my 1958 house in Minnetonka, Minnesota, and this is the report saying that when they started, the duct leakage was 164 CFM of duct leakage, and when they finished, it was 28.5, meaning, and you can see on the report there that it says I had about a 30.9 square inch hole to begin with, and it was down to a 5.4 square inch hole of leakage when they finished. I also did a TrueFlow test before and after the AeroSeal. And before the TrueFlow test, I was measuring 876 CFM at a static pressure of 0.56. And after the TrueFlow, I was measuring 874 at a static pressure of 0.49. Those are not reversed. But I think there may have been a slight mistake here in that I think possibly in the after test, I had my humidifier bypass open and maybe it was closed in the initial test. But even so, what didn't happen is my static pressure didn't go way up. My airflow didn't go way down. But my leakage was pretty modest. 163 CFM is not horrible. It certainly wouldn't pass code, but it's not awful. And so, yes, it's possible when you do duct sealing for the static pressure to go up, particularly if it's extremely leaky. If you have large gaps that are open, yeah, it could go up. but I think probably less than most people think. And if you think about it, a 30.9-inch square hole, that's smaller than a 10 by 4-inch supply register. And a house is going to have like 20 supply registers of that size. So if the holes you're sealing are equivalent to like 1/20th of your supply registers, it's not going to have a large effect on the static pressure.
Awesome. Thank you. Thank you very much, Steve. I see, I'll direct you to the chat to see that Matthew dropped in the link about how to be an approved contractor, but there's also a question about if NEEF requires any commissioning or verification of contractors. Matthew, would you like to take that one?
I thought when you began the sentence, it was commissioning or verification of the project, and then you said of contractors. I wanted to make sure I'm
sorry.
responding
Yeah.
correctly.
I mean, do you have requirements for the project? Any commissioning or verification projects that you require the contractors to perform? That was poorly phrased. Thank you.
Yeah, no, all good. The first answer is no. There's a bit more nuance. We end up working a great deal with different programs. So, for instance, we are close to kicking off a program in Georgia that would be that program that we are involved in is going to require that there be an audit done on the project, right? So it is, in that case, it's not necessarily our requirement, but it is a requirement of the program. Or we do work in New Jersey. We offer 0% financing in New Jersey. Every project must follow the Board of Public Utilities approved process to get a rebate. So there has to be a rebate, and that's how the 0% financing is arrived at, right? So we as a whole, and we also do programs where there's really very, very minimal types of requirements. So we do not require commissioning. The programs that sometimes will buy our rates down will certainly require that. And that really varies program by program, state by state, utility territory by utility territory.
Great. Thank you for that. So we have another question for Steve. Will TEC ever pursue register size TrueFlow devices?
We are working on a flow hood, and that's what you would use to measure at the supply registers. Yes.
Okay.
We used to have, for those not aware, we used to have a flow hood. It went obsolete about 8 years ago, and we're working on a new one. But yeah, it's not coming real soon. Got other products first.
There's a second one there. How do the entry conditions affect airflow measurement accuracy?
So the TrueFlow has a specification, which is that you need to have 6 inches upstream of the grid that's clear without any obstructions, and you need to have 2 inches downstream. So most systems don't have a problem with that. Most systems have that, but there are some cases where the filter is like right against the blower housing in an air handler. We did one that was like 1.25 inches away, and that will affect the measurement. So you need to take some measurements and make sure that you've got 6 inches upstream and 2 inches downstream of the grid. And in basically all those conditions, we're getting accurate flow measurements.
Okay, thank you. There's one more in the Q&A actually for you, Eric. Does Eric have anything to share from the FSEC NCS study?
Sorry, I had trouble turning my video on there.
No worries.
I'm sorry, which study? Was it the Building America study that they're referring to?
Yes, I think so. The one you referred to in your presentation.
Yeah, so, we've done a number of different things. We've actually looked at utility bills from some of the homes that participated in the program to try to I guess, reinforce what we think we already know, that addressing ducts at the time of HVAC changeout does have a measurable effect on utility bills. So we are actually able to see that. There are some energy reductions in homes that are receiving duct upgrades versus homes that aren't. We've also looked at the accuracy of the TrueFlow device in the field at being able to measure airflows and how that can integrate with some pressure pan data to really give a complete picture of the performance of the duct system. So we've had some success with that. And we've also learned about the value of these tools and financial resources from contractors and stakeholders that are actually using the product. As you'll see, a number of people chiming in the chat about how they're using them as part of their practice and how the data that's being produced by these tools is valuable in a number of different realms.
Great. Thank you so much. It looks like we have come to the end of the questions that I see in the Q&A. And aside from a volunteer to be a beta tester for the flow hood, I think we are ready to hand it back to you, Laura.
Yeah, thank you. I want to highlight that somebody asked Ryan to provide their email or contact info to send some materials. But if other of our panelists and presenters want to go ahead and do the same and share your email so that folks who attended this webinar can contact you, that would be great. I want to thank all of you for taking the time to join us today. Thank you both to our panelists and to our attendees. It has been a wonderful discussion. And I want to remind everyone that today's recording of the webinar will be available to all registrants, as well as this content will be available on the Building America Solutions Center website. And then please complete a short survey that is going to pop up when this webinar closes. It helps us improve for future sessions. And yeah, have a wonderful rest of your day. And we hope to see you at SIA's Southeast Energy Summit in Biloxi, Mississippi on November 17th and 19th. Thank you, everyone.
Thank you all.
Bye-bye. Thank you.